8.4, graphing rational functions. So now we're going to go more complicated than we did last time. We're going to expand on just reciprocal functions, which is last class, and now we're going to do all rational functions. So by the end of this lesson, hopefully we'll know how to graph any type of rational function. First up, let's talk about vertical and horizontal asymptotes. Like last time, vertical asymptotes we do the exact same way. We're going to set the denominator equal to 0. That doesn't change ever. Remember, that's the line you can't cross. Now though, we're going to get a little more complicated. They're horizontal asymptotes. Now the way we find horizontal asymptotes is by the powers. So we're going to have three scenarios. We're going to have the top power is bigger than the bottom power. So top bigger than bottom. So that's something like, for example, that's something like this. See how the degree on the top one is higher than the degree on the bottom one? We have a 2 and a 1. So top power is bigger than bottom power. When that happens, we have no horizontal asymptote. There's actually a special case where you have an oblique asymptote, but you're not going to cover that in algebra 2. So for us, if the top power is bigger than bottom power, you have no horizontal asymptote. So next up, what if the bottom power is bigger than the top power? So let's flip it around. Now the bottom power is bigger. So in that case, we say y equals 0. That's horizontal asymptote. The bottom power is getting so big, bigger than the top power. So you have like 3 over 1,000. It's essentially 0. So as you get closer to infinity, your asymptote is going to be y equals 0. Now, key thing to note, that's like what we did last class, right? Remember we had this last class? And I said the horizontal asymptote was always a 3. Well, it's because look at here, right? That the horizontal asymptote here, bottom bigger than top, is 0. And then you have a vertical shift of +3. So that's why the default was always 0, because the bottom was always bigger than the top in the last lesson. But then we had the vertical asymptote. So far, right? Top power bigger than bottom power is none. Bottom power bigger than top power is 0. And what if they're the same? Only thing left over. What if the bottom power equals the top power? So it's something to this effect. In this scenario, when they're the same power, what you do is you take the ratio of the highest powers. So we look at these two, they're both the highest power. We take the ratio, so this would be y equals 3 over 1, also known as this y equals 3. So then it's y equals the ratio. So that's how I found the powers. Horizontal, vertical asymptote, same thing as always, just set the denominator equal to 0. Horizontal asymptote, that one gets a little more tricky. Now it's so easy because you're just comparing things, but there's more scenarios. So top power bigger than bottom power, none. If the bottom power is bigger than the top power, then it's 0. Just think like you have like 3 over a billion, so it's 0 essentially. And if they're the same, then it's a ratio. All we care about is the powers. You take the ratio of the highest powers. So that's how I found asymptotes. Right? Again, here's the 3 scenarios. In this case, no horizontal asymptote. Right? In this case, the top power is bigger than the bottom power, like you can see right here. In the second scenario, if you look right there, the bottom power is bigger than the top power. So our horizontal asymptote should be y equals 0. And if you see it right here, y equals 0. And then the last one here, if we look at what we have, and if I didn't cross it out on accident, top power equals bottom power. So these are both, you have 2x and x, again hard to see. So you have y equals the ratio, 2 over 1, or 2x over x, which reduces to 2. So y equals 2 should be a horizontal asymptote. And if you look at what they draw it at, right here at 2. So again, to recap, horizontal asymptote, right? It's all about the powers. Top bigger than bottom is none. Bottom bigger than top is 0. And if they're the same, it's the ratio. Vertical, good old reliable, just like last time, just so the denominator equals 0, right? Because those are lines you cannot cross. You can't divide by 0. That's where it comes from. Now there's one last thing we haven't talked about yet. And that's a point of discontinuity, also known as the hole in the graph. Sometimes your graph has a hole in it. And that happens when stuff cancels. So when stuff cancels, you have a hole in your graph. So a good example, let's probably best to see by example. Let's do something like this. Kind of like they do right here. So in this case, let's say I give you this graph here. So before you do anything else, you're like, these cancel. So that means you have a hole in your graph. Now where does the hole happen at? It's just like a normal, like a vertical asymptote. You set this equal to 0. So my hole should be at x equals -1. So that's where your hole is at. So what does that mean? Well, look what's left over. You still have a graph there. You still have the graph y equals x minus 1. We know how to graph that. Y-intercept of 1, negative 1, should say. Slope of 1. Looks something to that effect. And where the hole? And where's our hole? As you said earlier, right? Our hole is at negative 1. If you want to figure out what it's at, easiest way to do is just plug it in. So y equals negative 1 minus 1 or negative 2. So our hole is going to be at negative 1 and negative 2. So you go negative 1, negative 2. You have a little hole in your graph. So those are the three things. The three things you have to find: vertical asymptote, horizontal asymptote, and holes. Again, holes come from cancellation. So if stuff cancels, you have a hole. If they don't, you don't have one. You can see another example right here. Right, they did kind of the same thing. X plus 1's canceled out. You had a hole at negative 1. So on your graph at negative 1, there's a hole right there. Okay, that's kind of the gist of all the setup. Now let's actually graph some things. So when we graph, these are the steps we're going to follow. First, step 1, let's find the horizontal asymptote. Easiest thing to do is look right here, right? That's the powers. And in this case, if you look at it, the top power is bigger than the bottom power. And if you remember, that is none, so no horizontal asymptote. So top power bigger than bottom power, we have no horizontal asymptote. So next step, factor if possible. So we're going to try to factor this. The reason we want to factor in case we have any holes, right? Stuff cancels out. So remember, we got to think of two things that multiply to get negative 6, but add to get 1. So x minus 3, x plus 2, right? They multiply to get negative 6, but when you add them, you get negative 1 over x plus 1. Well, nothing cancels, right? Nothing cancels, so there's no holes. And the last thing we do, let's find some vertical asymptotes. Or not the last thing, I should say the last one of these. Vertical asymptotes, remember that the way you find that, it's always set the denominator equal to 0. It never changes. So x plus 1 equals 0. When you get x equals negative 1. So we do have a vertical asymptote. We don't have a horizontal or holes, but we have a vertical asymptote. Now, so we can make it graph a little better. Let's find the x and y intercepts. So it's let's find the x-intercept and the y-intercept. So if you guys remember x-intercept, you just set y equal to 0. So let's go back to our equation right there. We're going to have 0 equals x minus 3, x plus 2 over x plus 1. Right, that's how we find our x-intercept. You set y equal to 0. And then the way we saw this, I know it looks a little scary. Don't freak out. You multiply both sides by x plus 1. And the x plus 1's cancel. 0 times anything is still 0. So you get 0 equals x minus 3, x plus 2. Look, it's already factored for you. So my x-intercepts are at 3 and negative 2. So 3, 0, and negative 2, 0, if we want to be exact about that. Those are my x-intercepts. Y-intercept. Well, we set x equal to 0. So y equals, let's plug in 0 for everything. 0 minus 3, 0 plus 2. It's actually easier to plug into the original function, but I'll skip that for now. And you get negative 3 times 2, so I get negative 6 over 1, or just negative 6. So my y-intercept is at 0 and negative 6. So I have a y-intercept, I have a couple of x-intercepts, I have my vertical asymptote, I have no horizontal, no holes. What do we do next? Well, I like to draw the vertical and horizontal asymptotes. Let's plug in everything we have basically, right? So x equals negative 1, vertical asymptote, so remember a line we can never cross. I have a y-intercept at 0, negative 6, so like let's say 1, 2, 3, 4, 5, 6. I have x-intercepts at 3 and negative 2, so 1, 2, 3, and negative 2. So I have something like that going. So how do I fill out the rest of this? Well, there's two ways that are generally used. Way 1 is that you use your calculator, and that's the way I'm actually going to do. But before we do that, I'm going to show you right now. The other way to do is use a table. So like, what they always do is if you don't have a calculator, just make a table, an x, y table. Now, you can fill out some more values over here. I already have negative 2. I can do like negative 3, negative 4. On this side, we already have 0 and we have 3. We could do like 1 and maybe like 5. Then you can just get more points and plot it. Right? You know me, anytime we have a table, I'm like, why would we do a table? Let's just graph it. So that's what we're going to do. Bring over my handy calculator over here. Now again, you might say, why won't you just graph from the very beginning? I'm going to ask you to tell me I'm going to ask you to tell me the horizontal vertical asymptotes, the holes. I might ask you for the x and y intercepts. I like to see the asymptotes graph. I like to see the asymptotes drawn on your paper. If you just draw me lines, I'll mark you down. I want to see the asymptotes. So in our calculator, how we do this? We go y equals, or turn it on. Y equals over here, right? Now I'm telling you right now, it's actually easier if you do the whole graph first. You can do the factor one, but it's a lot easier if you just do the original graph. So a couple ways to do fractions. One way is use your parentheses, like that's the most important thing in the world. Use your parentheses. That's one way. Other way, if your calculator is updated, you can do alpha y equals, and it gives you this little function here. That lets you put a fraction form, and then you just type it in the way you see it. X squared minus x minus 6 over x plus 1. Hit graph. We got this and we got that. If you see our graph down here, it's gonna be, we could do the same thing. So go like this. I can't go past that. Same thing down here. I can't go past that, and it kind of curved up like that. Again, that's the same graph I would have done if I would just filled out my table, as you can kind of see if you put second table, right? Again, why don't we just go straight to the calculator? Because I want to see, you have to find horizontal vertical asymptotes. That's super important. It's like, for me, it's actually the main part of this whole lesson. That's going to stick with you for the next couple of years. So I want to see you do those. I want you to see them, plot them. And then from there, you can use your calculator to fill it out. So that's the first one. Let's do some more. This next one here, right? Same steps. Let's find our horizontal asymptote first, because that's the easiest thing to find. Just look at the powers. And in this case, they're the same power. Top equals bottom. So that's the ratio. And in this case, they both, remember, while we're looking at the coefficients, they're both 1 over 1. So y equals 1. Right? It's the ratio of the highest powers. And then we look for factor. We can't factor it. Holes, if anything cancels, nothing cancels, so no holes. That says holes. There's no holes. Vertical asymptote. Set the denominator equal to 0, right? Always the same thing. Nice and reliable. X equals 5. So we have a vertical and horizontal asymptote. Again, for my sake, I might probably ask you to find the y and x intercepts. Y intercept, x equal to 0. So it's also a good thing to know how to do in general, because it's going to happen a lot. So you set your x equal to 0. So y is an equal to 0 plus 3, 0 minus 5. Y equals negative 3/5. X intercept, right? Set y equal to 0, sorry. So it's the opposite one. So that's the f of x. So that equals 0 equals x plus 3, x minus 5. Multiply both sides by the denominator, so it goes away. You just have this, and you get x equals negative 3. So negative 3, 0 is my y-intercept, x-intercept, and 0 and negative 3/5. And now once you have all that, we can just graph it. That's what I call a straight line. Again, always start with asymptotes. So y equals 1, so like this. X equals 5. 1, 2, 3, 4, 5. Let's use our points. 0, negative 3/5. So 0, negative 3/5 is right there. Negative 3 and 0 is over here. So I kind of know what this graph looks like. So I'm going to go down here. I'm not sure about this graph. Right, so a couple ways we can do it. We can make a table. We could try to look at our positive and negative thing, but for the most part, once you get that, we could go ahead and use our graph, our calculator. Right, we go to y equals, let's clear that out. Alpha y equals x plus 3. Again, if you want, you can also just, by hand, you can just make a table, plug in values. But we have technology. It's 20 seconds. And we get that. So, as I said, our graph, right, curves from here to there. Remember, asymptotes is like, you could go past that, but it just lets you know as you get closer, we should be hitting toward. In this case, we shouldn't pass it though. And this graph, remember, I should never pass a vertical asymptote, so this goes down and gets close. See on this side, kind of hugs the corners. And that's how you graph that one. Next one. Let's do a few more just to get the rhythm of it all, right? So horizontal asymptote goes first. Remember, it's all about powers. In this case, the bottom power is bigger. Bottom bigger than the top. So y equals 0. Done. Next, anything cancels, nothing cancels out, so no holes. So let's do let's go straight to vertical asymptote. And then remember the way we do that is the denominator equal to 0. Now in this case it has a square, so we square root it. I get x plus 4 equals 0, x equals -4. That's my vertical asymptote. And like we've been doing, let's find the x and y intercepts. So again, x-intercept, right, you see the y equal to 0. So I'm going to get 0 equals 1 over x plus 4 squared. And remember the way we solve this? We multiply both top and bottom. We multiply both sides by the bottom. Well, what happens here is everything kind of cancels out. Right? These cancel. 0 times anything is 0, so you get 0 equals 1. That's a wrong statement. 0 does not equal 1. So what happens? There's no x-intercept. Right? Until you get something false like that, that means there's none of that. No x-intercept. Y-intercept. Right? So again, we're going to set x equal to 0. So we're going to have y equals 1 over 0 plus 4 squared, which is 1 over 4 squared, which is 1 over 16. So 0 and 1/16. So let's graph this. Right, again, always let's do our asymptotes. So I get 0, horizontal to 0. Vertical is at -4. And I have my y-intercept at 0 and 1/16. Right, so again, it looks like something like this. And then last time we did this and this, but it's squared, so it's actually going to go up here. But if you're not sure, you can always make a table and put values in, or use your handy dandy calculator. Right, let me do this one without the function. So if I was to do it just like without the fancy function, you just do 1 divided by, what we need is parentheses. Parentheses x plus 4. Works the same way, not as pretty. And you get this. And see, both sides is positive. And that's because it's squared. So right, if you plug a negative value, you're squaring it a positive. So actually, in this case, they both sides go up. Again, can't go past that. Hopefully your graph's nicer than mine. You get something to that effect. Let's do a few more so you get, again, the flavor of all the different types we're going to see. So the next one here, right, starts the same way. Horizontal asymptote. Top power bringing the bottom power, that is none. Holes. So remember, the next thing I do is factor. So it actually does factor. 2 things I multiply get -5, I have to get 4. X plus 5. X minus 1 over x plus 5. Hey, we have a hole in this one. These cancel. Remember, it's like vertical asymptote. Where does it, like, what makes it 0? X equals -5 is the hole. So we have this left over. F of x equals, what didn't cancel out, x minus 1 on top. And if you want to figure out where the hole is at, you just plug it into the equation. So -5 minus 1 is -6. My hole is at -5 and -6. So we have that. Vertical asymptote. Now look what's left over. Remember, our graph is this now because everything else canceled out. There's no denominator, so there's no vertical asymptote. I'm going to skip the x and y intercept because look at this. I don't need to. I know how to graph that. Right? Y-intercept is -1, so start there. Slope of 1 over 1, right? Good old linear algebra. Get something like this. Don't forget there's a hole at -5, -6. So let's say that's -5, that's -6. It should be on the line, so that's a hole right there. Right, so graph, hole, graph. Right, there's one part of this graph that you cannot have a value, and that's at -5. And that's how you do one with the hole. The next one is also, it's a little weirder. So let's do the same thing, horizontal asymptote. Right, remember powers. Now look at this one. What power is bigger? The bottom is, there's 2 x's. If you actually multiply it out, you get like x squared, blah, blah, blah. So the bottom power is actually bigger. So bottom bigger than the top. So y equals 0. Any holes with cancellation? Nothing cancels, so no holes. Vertical asymptote. Remember, so the denominator equals 0. Now this one has 2 of them. So we have x equals -2 and x equals 5. So 2 horizontal vertical asymptotes. And then let's do what we always do. Let's do the x-intercept except for the last one. I guess not always. X-intercept, set the y equal to 0. So it's going to be 0 equals 2x over this stuff. Remember what happens here? You just multiply both sides by the bottom. They cancel out. 0 times n is still 0. You just get this. Divide by 2. And then x equals 0. So our x-intercept is 0, 0. That's also our y-intercept. So honestly, I'm not even going to solve the rest because it's going to be the same thing. So if I get to the y-intercept, right, x equals 0, you get the same thing. You're going to get y equals 0 because 2 times 0 is 0 over something, which is 0. So x and y intercepts at 0, 0. Let's, as always, graph horizontal asymptote. Our vertical asymptotes, you have 2 of them this time, -2 and 5. Again, so I have like 3 different graphs here. I'm going to have one on this side. Remember, it can only be top or bottom. Can't have both because then it wouldn't be a function. And you can have one in the middle, right? Either top or bottom. Can't have both. Or actually, you could have. Sorry, the middle could go either way. That was wrong. The middle could go kind of either way. You'll see that. And on the right, you can have either top or bottom. So again, how do you do this? Well, you can make a table. You can use your monotonicity. We have only 1 point so far. It's our x and y intercepts right there. Or you could cross the horizontal one. Our graph's probably going to cross it. You can't. All it does is tell you how it goes on at the end. You can't cross the vertical one. So anyway, the way we're going to graph this one, we don't want to make a table. We're just going to put it on our calculator. Turn it on again, I guess. So let's go. Alpha y equals, right? Easiest way to do it. Also the prettiest, 2x. On the bottom, make sure you use your parentheses. X plus 2. Parentheses, x minus 5. And you get this. And again, notice how the middle one, it crosses the horizontal. So you could do that. Horizontal just doesn't do that. All horizontal asymptote tells you is the endpoints. Right? So it looks like it's going to be down left, like a x cubed graph, and then top right. Right? So again, kind of like this. Not my best. This one goes like this, cuts across and goes down. Again, you could cross over the asymptote, and then this one was on top. You graph like that. Next one, let's do this one real quick. We're almost done. This one right here. Right, same concept, horizontal asymptote. Look at the top power is bigger. So none. No horizontal asymptote. Next, remember, second step is factor if you can. Now, a lot of people overthink this. Remember, the first step when you factor is what they have in common. And on top, they all have a 3 and an x squared. And if you notice, these match. And they'll be multiplied, so you actually cancel these out. So where's your hole at? Well, it's, remember, as always, you have to set that equal to 0, just like find a vertical asymptote. That does factor. It's x squared. That's how you solve it. You factor it. X plus 1 times x plus 1. Or just x equals -1. So we have a hole at x equals -1. Remember, if you want the y value, if you want the actual point, well, you look at what's left over. So this cancels out. Our new function is pretty much just this 3x squared. So if I actually want my point, it's got to plug it in. So 3 times -1 squared, which is 3 times 1. Remember, this goes first. So 3. So my hole's at -1 and 3. Now, so we have horizontal asymptote, none. Hole at -1, 3. Vertical asymptote, so denominator equals 0. Again, notice no vertical asymptote anymore. There's no denominator. So no vertical asymptote. It all got canceled out. And then we could find the x and y intercept. I'll tell you right now it's 0, 0. Because we know how to graph this. It's a parabola. With the vertical stretch of 3. So something like this. Now at -1, 3, I should have a hole. So at -1, 3, there should be like a hole right here. Other than that, goes on. Oof, not my best graph, but that's the idea. Right? Anytime something cancels out, that's a hole. You put a hole in your graph. The rest of it do the same thing as always. There was no horizontal asymptote, there was no vertical asymptote. You just end up having a parabola. Now let's look at this application problem. Right, this stuff comes up in real life. Now, as always, keep in mind when they always ask you, well, what part of it do you use? What domain values work? Real life problem, positive values, right? We're not gonna use negative values. We're not gonna have negative sales or negative something. So there's a problem here. Company uses the formula S of X equals 45X plus 25 over X plus 1 to determine the salary in thousands of dollars of an employee during this X year. So X is years. Graph S of X, what domain and range values are meaningful in the context of the problem? What does the mean of the horizontal asymptote in this graph? Right, so they want me to graph that. As always, let's do what we always do, horizontal asymptote. In this case, they're the same, right? So top equals bottom. So it's the ratio. Which in this case is going to be 45 over 1, or just 45. So that's my horizontal asymptote, y equals 45. Nothing factors, so we're going to skip holes. Vertical asymptote, so the denominator equals 0. I get x equals -1. That's my vertical asymptote. We could find the x and y intercept. Let's do that. X-intercept, set the y equal to 0. So to me, 0 equals 45x plus 25 over x plus 1. Remember, you always just multiply both sides by x plus 1. You get 0 equals 4x plus 25. When I solve that, I'm going to get -25 divided by 4. -25 over 4 equals x. So about like 6.25. The y-intercept, so x equal to 0, a lot simpler. So 25 there, sorry. This plugged in 0, right? And these zeros, that's 0, that's 0. You get 25 over 1, so 25. That's my y-intercept. You want me to graph it? Y-intercept's at 25. I have an asymptote at 45, so way up there. Let's make that the asymptote, because I should know better. Y-intercept's right here at 25. And the vertical asymptote's at -1. Now, I already have my y-intercept, and my x-intercept was at -6.5 actually, so this is -1, -6.25. So, as always, let's graph this. So turn it on. Y equals, I'm going to do alpha y equals that one, 45x plus 25 over x plus 1. Right? Hopefully it's like, oh, it's easy now. Graph it. And you get this, you're like, I don't see anything. Well, it's because that's how calculus works sometimes. It's going to be a little funky. Right, so if we're not sure, you can always hit our table. Now look at what's going on at 0. We're showing at 25, like we said, right here. At 1, we're at 35. And then it gets really close to 45 already. You see 40, 41. Our graph's doing this right here. And remember, our window is really off too. If I wanted to fix, I could actually fix our window. You can do like a little zooming out thing. But let me go to the other side first. Look what's going on this side. After -1, I got 65, 55, 50, 49. This side, it's going like this. So I think my answer here is a little off. Yep, it was 45, not 4. So it's something super small. That's why it made sense. It was right here. A lot more sense now. And wait, that's our graph. Let's go over a couple things they asked, right? What's the domain range values that are meaningful in the context of the problem? Now, again, we're talking about salary. X, so X here is years. And S is salary. It's my Y value, my Y-intercept, my S is salary. So which domain values are meaningful in the context of the problem? Well, you can have negative years, so 0 to infinity. And my range values also, you're not going to have negative salary. So in this case, actually, I didn't really care about where it starts off, which is 45. Well, sorry, 25. That's my y-intercept. 25 to 45. I also accept 0 to 45. Right, there's a horizontal asymptote right there we can't go past. We can't go past. We could hit it, but we're not going to go past. What is the meaning of the horizontal slope in this graph? That's your top salary. Right? They're not going to let you go past that. So that's your max salary right there. You hit a glass ceiling.